Okay. All right, so let me just review again. So how this all worked. So the whole thing was that right, that you invert the product rule. So yeah. All right, so let's just do some exercises then. Man, I cannot get this tape to hold the fucking thing. I don't know where I put that tape. All right, well, let's just fix it. Okay. All right. We can do this. All right. So, bunch of integrals today. Okay, and they provide, they say u is equal to ln x, dv is equal to x squared dx. So then we integrate both sides, we get v is equal to x over 3. I don't know, are you supposed to have a plus c? I think it doesn't matter. Okay, so the idea was that, okay, let me just always derive it, because I'm never going to remember the formula. So if we have the integral of u prime v plus v prime u d what is the differential? Oh, no. Okay, so wait, I'll write it the other way. So if you have the integral of f of x, f prime of x, g of x, dx, or plus g prime of x, f of x, dx. If you have this, you can write it as two separate, this integral we know is going to be equal to f of x, g of x. So what we can do is we can split this into f prime of x, g of x, dx is equal to f of x, g of x, minus the integral of g prime of x, f of x, dx. So this is that. So then the formula is u so they're saying take u equal to ln x, because then shouldn't the formula be, okay, so to rewrite this, you say let equal to f of x b equal to g of x. Okay, so then we get du is equal to f prime of x dx. Oh, they switch the other side. So they flip this around. So they take this and they make it integral of g prime of x f of x dx is equal to f g minus f prime g. So and then dv so right, so that's deriving that. But so the rewriting into the formula is we can take this and we can just make this the integral of v du because we take v and du. Oh, wait. This is wrong. This is going to be the integral of u dv. And this is going to just be, this is just going to be uv minus g. So this is going to be v du. Okay, so now that we've derived the formula, and let me get my hat. Okay, so the next step is we're going to substitute in here. So we have u, okay, and then du is equal to dx over x. So now we can just say integral of ln x times x squared dx. Oh wait, no, this is the original integral. So we can rewrite this as wait, I don't know how to do it then. Okay, so this is u dv. Then we're gonna get ln x times x3 over 3 minus, and then this is gonna be v du. So this is gonna be x cubed over 3 times dx over x. So then this cancels with this to become a squared 1/3. So then we're gonna get, but then that cancels. So the integral is Yeah, so you typically, okay, so you do typically take the G prime equal to the, okay, wait, let's do the example problem one more time. So we have integral of x sine x dx. So what we do is we take, let u equal x. Well, okay, wait, let's do it the first way and then the second way. We have time. So f of x is equal to x, and g prime of x is equal to sine of x. So then it fits that this is actually this left-hand side. No. Okay, so now we're gonna get f prime of x is equal to 1, and g of x, because here you integrate, I mean minus cos x. So now we can just substitute this in. So we're gonna get minus x cos x minus the integral of this is going to be g prime. This is going to be sine x times f times f. What? Oh wait, no, because this was wrong. Yeah, this is the wrong way to do it. This is going to be, because this is f g prime. So this is going to be f g minus g f prime. So this is going to be the integral. Oh man, you can't see anything. So this is just going to be minus cos x. Okay, yeah, dx. So then these cancel, and you get the integral of cos is going to be sine, so plus sine of x. So this is the plus c. This is the full thing. Minus x cos x plus sine. Okay. All right, so we worked through that example. Okay, so we get Okay. Yeah, let's go back to problem 1. X squared ln x dx. All right, so what do we have here? We're going to take d. Wait, oh, what does it tell you? It tells you take u equal to ln x and dv equal to x squared, which makes sense because if you took dv equal to ln x, then you'd be like, how do I integrate that? Because the integral of ln x is this weird expression. So now v is equal to x cubed over 3, and du is equal to dx over x. So now here we're going to get, so this is dv, and this is u. So we have u dv is equal to, and now we're going to get ln x times x cubed over 3 minus the integral of what is this? This is gonna be v. This is gonna be x cubed over 3 times dx over x. Right, we just did this one. So this cancels to a 2. This goes outside to 1/3. Then we get x cubed over 3 ln x minus x cubed over 9 plus c, which is equal to x cubed over 3 times ln x minus 1/3 plus c. I don't know if that's correct. Okay, yeah, so we did get it right. All right, cool. All right, problem 2. Integral of x cos x dx. You take u equal to x and dv equal to cos x dx. So then v is equal to the integral of cos is sine, so we're going to get sine x. Then this du is equal to dx. So now we're going to say that what is it? It's going to be, this side is fg prime dx or something. What is it? It's I do kind of memorize that formula, but u dv. But you could just as easily do. Well, but the whole. Oh, but okay. But the whole point is that you let this side equal what you originally had. So you're gonna have x cos x dx. That's what keeps tripping me up here. So then here you have x sine x minus the integral of sine x dx. So and then the integral of sine is minus cos. So I think it's x sine x plus cos x plus c. X sine x plus cos x. Okay, cool. All right, we're starting to get it, but it's slow. Okay, 3 is integral of x cos 5x dx. So we're going to say u is equal to x, dv is equal to cos 5x dx. So then du equals dx. V is going to be equal to sine 5x over 5. Okay, so now this is going to be equal to x over 5 sine 5x minus the integral of, it's going to be 1/5 sine 5x. Is that true? I guess that's true. I guess the v part, okay. All right, so then we're going to get, the integral of a sine is going to be minus cos, so there's going to be plus 1/5. Let me check. Yep. Okay, so we got this one right. All right, so let's do number 4. Integral of y e to the point 2y dy. The integral of e to the point 2y dy is going to be equal to, so this is like 1/5, right? So if you shouldn't it be, I think it's gonna be 5e to the 1/5 y, right? Because if you take the derivative of this, then you get, yeah, so this is that. So then v is equal to 5e to the 1/5 y. du equals dy. So then we're gonna get, this is equal to y times 5e to the 1/5 y minus the integral of, and then we're gonna get v, which is, so we can pull the 5 out from there. I think it's just gonna be, oh, we can pull this out even more. Yep. All right, let's see. Actually, wait, but isn't, all right, well, if we fail, we will switch it around, but isn't it really hard to integrate this, e to the minus 3t? So wait, let's try the other way around then. So instead, if we do u is equal to e to the minus 3t, then du is equal to minus 3 e to the minus 3t dt. And then if we let dv equal t dt, then v is equal to t squared over 2. So then we're going to say u e to the minus 3t times v, which is t squared over 2, minus the integral of t 1/2 t squared times dv. But that's e to the minus 3t. Whoa. Wait. I do this wrong? Wait, maybe this isn't the hard one. I thought it was, though. I'm pretty sure that that's a hard one, too. Oh my god, my mouse is so bad. Yeah, no, wait. I don't know how to do them. Because I know that these... Oh, wait. You know what? No, I have this wrong. Yeah. I'm seeing stupid. This is easy. It's when you have e to the minus t squared or something that's hard. Okay, so we're gonna continue as before. We're gonna let so the integral of this. I don't know how to integrate that. How do you integrate that? Oh wait. It's just gonna be e to the u of x or something like that. Or let's call it f of x. We're gonna just get f prime e to the f, right? So then we're just gonna get minus wait, isn't it just gonna be oh no, this is the derivative. That's not right. I'm gonna ask. I don't know how to do that one. What the hell? Okay, wait, but the derivative is yeah, minus 3e to the minus 3t. So then yeah, so then we should just get minus 1/3. Oh my gosh. My mouse is broken, dude. I'm just gonna go get a temp mouse because I can't restart and end the stream, but my mouse is broken. Okay. All right. Got a mouse. Okay. I don't think that's right. Oh, because this is... Yeah. Okay. All right. All right. That was kind of a minor hiccup, but we're good. So this is correct. So now that we have, so this is V. So now we just need to do, so this is integral V, no, 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 U dV. So then we have is equal to, and this is going to be UV, so it's going to be T times minus 1/3 e to the minus 3t minus, and then this is going to be v du. So this is going to be, again, this is going to be a plus 1/3 e to the minus 3t dt, because du is just dt. So then we're all good there. So now this just becomes this becomes a minus 1/9 e to the minus 3t plus c. And this becomes t times minus 1/3 e to the minus 3t. So I think we can pull out minus 1/3 e to the minus 3t, t minus 1/3. A lot of these solutions look like this. Kind of interesting. So I'm pretty sure that this is our solution. Okay. Let me just double check what I have. Yep. All right. So these are not so hard. Maybe we should skip to some of the harder ones. Now let's do 7. 7 looks kind of hard. 7 is the integral of x squared plus 2x cos x dx. Oh, I think that this might be one that you have to do twice. So if we let u equal x squared plus 2x, then du is equal to 2x plus 2 dx. Then dv is equal to cos x dx. And v is going to be equal to sine of x. So now from here, we're going to get, this is equal to x squared plus 2x sine x minus the integral of v du, which is sine x times 2x plus 2 dx. Okay, here, so then we now need to do another one. So we have, so in here, u2 is equal to 2x plus 2, du2 is equal to 2 dx. Okay, then dv is equal to sine x dx. Then v is equal to minus cos x. Okay, so then we get this next one, which is we're gonna uv, which is minus cos x times 2x plus 2 minus the integral of this is v du. This is gonna be, so this is a plus cos x times du, which is just 2 dx. So this is going to be 2. We can get rid of this. And then the integral of cos is just sine. So I think the final answer is going to be x squared plus 2x times sine of x. And then I think it's a minus cos x times 2x plus 2 plus 2 sine x plus c. So then this becomes a plus, and then this becomes a minus. No. What? No, we did. We got it right. Okay. All right. I just was looking at the kind of okay. Um. Okay, let's do 9. So in this case, we're going to get 1 over times, what is this going to be? This is going to be 1/3 x to the 2/3. So isn't that just equal to 1 over 3x? I think that's right. Du is equal to 1 over 3x dx. So then, all right, so we're going to get vu, which is ln x to the 1/3, times x minus the integral of x dx times 1 over 3x dx. So then these cancel. So then you're just going to get x. So you're going to get x times ln x to the 1/3 minus 1 plus c. Oh, 1/3. Wait, I did this wrong. Oh, what they did is they rewrote ln x to the 1/3 as 1/3 ln x. Okay, so then they were able to just pull out this 1/3. But I don't see why I got a different answer. I'm missing a 1/3 here. But where is the 1/3 going to come in here for this? Oh, yeah, it's right there. Right? Wait, no. This should be u v. All right, let's do it again. I don't know how that got messed up. Okay. All right, so we have integral of ln x to the 1/3. This is equal to 1/3 integral of ln x dx. And I think we can just remember from before 1/3 x ln x minus x. All right, fine. Yeah, I did want to do one of these crazy integral of, make sure that it's all okay. This is gonna be the integral of arc sine x dx. Okay, so we need to let u equal a sine x and y equal, or dv equal dx, then v equals x, then, but here we need to do this crazy thing that I can't remember. It's going to be sine u equals x, and then we integrate and we get, oh wait, no, we don't integrate. We're trying to find du. We d dx. d dx. So we're gonna get u prime cos u is equal to 1. Then you get u prime is equal to 1 over cos, but then cos is equal to 1 over 1 minus sine squared 1/2, and then this just becomes 1 over 1 minus x squared 1/2. Okay, so this is, so du is equal to dx over 1 minus x squared to the 1/2. All right, so that's deriving the derivative of arcsine by using, what do they call it? Implicit differentiation. Anyways, so at that point you can do, so now we can, so this is going to be, so it's uv minus v prime du. This one is u dv. And so u dv, so uv, so u is a sine x times v, which is x, minus the integral of is that right? Why do I always forget this? I mean, it technically doesn't matter which one, right? But I just want to go look. Yeah, v du. Oh wait, that's why this is wrong. It's just v. So this is going to be x du, which is, oh god, that's ridiculous. Dx over 1 minus x. I think you have to do a second one, right? You probably have to do a second one, but I don't know. I always get so lost in the weeds when there's a second one. Dude, integration is so boring. Oh my god. But I gotta just practice because it's been so long. All right, so if we let okay, so when we do this one, so we're doing integral of x, we're doing integral of x times 1 over 1 minus x squared to the 1/2 dx. So if we let u equal x and dv equal, is that what we want to do? Because doesn't this have a clean integral or something? I think that 1 over 1 minus x squared to the 1/2 might have a clean integral. So this is going to be dx 1 minus x squared to the 1/2. I can't tell. How do you remember this stuff? Hold on, let me just try to compute it. Because, well, isn't this just going to be arcsine? So then we get du is equal to dx. Then we're going to get x over, so we need to take this integral. We need to take integral of 1 over 1 minus x squared square root dx. But I'm pretty sure that this is a sine. Is this not a sine? So then we're just, so it like flips back around. And you're going to get x a sine x minus the integral of a sine dx, or du, which is dx. So this is the second part. Okay, so we're good so far. So then we get, so then we get an a sine x minus this. Now this integral, okay, wait, hold on. See, this is a good problem because instead of trying to redo this whole thing, what you're supposed to do instead of a second integration by parts is you're supposed to say, do a u sub. So, okay, so we have x over square root of 1 minus x squared dx. Let u equal 1 minus x squared. Or wait, let's call this, w. So then dw is equal to minus 2x dx. So then this means that dx is equal to dw over minus 2x. Okay, so then rewriting this integral, we can just pull the minus 1/2 out. Oops, there we go. We pull the minus 1/2 out, and then we get x over root u times dw, this is w, over x. So this gets canceled, and then we just left with the integral, minus 1/2, the integral of 1 over, which is just going to be w to the minus 1/2 dw, which is equal to, I think that this becomes 2w, right? To the 1/2. So 2 root w times minus 1/2. So then it just becomes minus root w. So that integral, this is a really good problem because it shows you, it's like you're learning these tricks, but if you do them in isolation, then you don't see how to combine them. But okay, so we're here. So I think it should be a sine x a sine x minus the square root of w, which is 1 minus x squared plus c. That's all it is? Cool. Wait, how did it get a... Oh, but then this minus is this minus. That's going to be really annoying to remember. Okay, that was fun. That was a good one. Okay, the next one is, let's see, what can we do? Arctan 4t. All right, let's do that one. I don't know how many of these we should do. Maybe we should do like some of the hardest ones. Ooh, let's do a hard one, yeah. All right, let's start with something semi-easy. A tan 4t dt. I mean, even this one is brutal for me. So, how do we do this? we let u equal a tan 4t, then how do you take the derivative of a tan? You let tan u equal, wait. We take tan of both sides, then we're going to get tan u is equal to 4t. Then you take the derivative. The derivative of tan, I think, is secant squared. So then you get, I think you get u prime sec squared u is equal to 4. So then you're going to get 4 over sec squared u. And then there's some identity here that I always forget. But we could just write this as 4 cos squared u, and then cos. But the thing is, we're trying to get a tan in there. What is that identity? It's something like. All right, let's just draw the triangle. I don't even care. Okay, so tan is b over a. Sec is c over a. So if we have a c squared over a squared, I think we can write this as a 1 minus b squared over a squared or something like that. Because then if you multiply both sides by a squared, you get a c squared, a squared. This can't be this has to be a plus. And then you get the Pythagorean identity. So this is true. So I don't know how I came up with this. I just sort of felt it in my bones, I guess. But so yeah, so this becomes u prime is equal to 4 over, and we have a sec squared, so this is just going to be 1 plus tan squared u, which means, and we can rewrite that as 4t, so this is going to be 4 over 1 plus 4t squared, which is equal to 4 over 1 plus 16t squared. So I think that this is dx du is equal to, so that's du. And then I think, what do we call it? We're just going to say that dv is equal to dt and v is equal to t. All right, so now we can proceed with the integration. What do we need? We need, so this is going to be u, which is a tan 4t times v, which is t, minus the integral of t times 4 over 1 minus 1 plus 16t squared dx, or dt. And what is that really? Oh, I think we can do a u sub again here. So if we have 4t over 1 plus 16t squared, if we take u equal to, or let's say w again, w is equal to 1 plus 16t squared, then dw is equal to 32t dt. So then we can pull out like, so then we get, so wait, but this is dt is equal to dw over 32t. So we're going to get we're going to get the integral of 4t over w times dw over 32t. So this t cancels, and then you get 1/8, and you can't see, 1/8 of 1 over w dw, which is equal to ln of 1 plus 16t squared over 8 plus c. So this is that. So I think the full answer is then t times a tan 4t minus 1 over 8 ln 1 plus 16t squared plus c. Let me double check. That one's kind of tough. 11. Oh, let's go. Let's go. That was easy, bro. I wasn't worried for a second. It was easy as hell. Yeah, I was just playing earlier. That was easy. I'll be right back. Alright, that was fun. This one was hard. Alright. Okay. So, what is next is, let's see, what problems can we do? This one. Ooh, this one could be interesting. Hyperbolic. I don't know about hyperbolic. I think maybe we could just move on to the next section. I get the idea. Make a substitution and then use integration by parts. That could be interesting. All right, let's just read on. One sec. I'm gonna get my jacket. Okay. Trig integrals. Use certain trig identities to integrate certain combinations of trig functions. We start with powers of sine and cosine. Subbing u equal to cos x isn't helpful. We can then evaluate the integral by subbing u equal to sine x. You get 1 minus... Wait. Wait, how does that work? Because if you take the du equals... Oh, so then... Okay, so then this just goes away. Interesting. Okay. Yeah, all right, so let's look at this then. Sine to the 5th cos squared. We left with a single expression in terms of sine with no extra cos factor. Instead, we separate... Right, so we got sine squared cos squared sine x is equal to 1 minus cos squared cos squared sine squared. Substituting u equal to cos x, we have... Okay, we do this. We do this. Okay, and then that becomes minus du. Because it eats this part of it up. Oh, wow. That's kind of cool, actually. You kind of need an odd power. Oh, geez. Okay, so we should remember this half angle thing. So this one... Oh, okay, so you sub in the... You sub in this. Wait. Oh, gosh. Wow, that's a brutal integral. Right. Yeah. Okay. I don't know how many problems of this I'm going to do. But man, there sure are a lot of rules for this stuff. Okay. All right, maybe we'll come back to that, but I just don't see that being on my test. And finding the area of a circle or an ellipse. I think honestly, only the first quiz is gonna have a lot of this calc stuff on it. Okay, let me at least read this, not blow past it. So this becomes, let me just write that down. So if you have a squared plus x squared square rooted, and then you sub in x equal to a times tan x. Then you get a squared tan squared x plus a squared. So you get a squared times tan squared x plus 1. But this is secant squared. So you get a squared sec squared square rooted. So then you get a absolute value sec. Okay. So you get 9 sine squared theta. So you can pull out the 9, you get 1 minus sine squared. 1 minus sine squared is cos squared, right? So, yeah, then you get 9 cos squared, then you get 3 absolute value. Okay, cool. Man, there's so many. It's like, there's just so much. Okay. This one I did want to do because I feel like a partial fraction could come up on this test. Holy fuck, I haven't done polynomial long division in like polynomial long division is pretty sick. Oh, here we go. Okay, wait, hold on. I wanna do this. That's fun, man. All right, so we have x cubed plus x divided by x minus 1. Okay, so then we do x squared. So then we get x cubed minus x squared. So then we're going to do minus x cubed minus, or that's going to turn into a plus x squared. So then you end up with x squared plus x, right? So then you're going to do plus x, right? So then minus x squared minus x squared minus, no wait, is it a plus? It's a plus x. So then you get 2x, right? So then you do plus 2. Oh, nice. That's what we got. Then you do plus 2, and then you do minus 2x plus 2. And so then the remainder is equal to 2 over x cubed plus x. Oh, it's not, no, it's not that. Because, okay, so currently you have 2 as the remainder. Yeah, why would it be that? It would be, no, it would be 2 over x minus 1. Okay, all right. So then you do this, then you, okay, so, wow, I'm reviewing a lot of stuff that I haven't seen in forever, man. The next step is the factor the denominator q as far as possible. How do we do the partial fraction thing, though? Case 1 is a product of distinct linear factors. I would like to look at chapter 8, arc length, maybe. All right, so we have the integral of x squared plus 2x minus 1 divided by 2x cubed plus 3x squared minus 2x dx. Okay, so we can factor out an x from the denominator. Since the degree of the numerator is less than the degree of the denominator, we don't need to divide. We factor the denominator as, okay, so since deg of p is less than deg of q, we now jump to factoring q. All right, so now we get x times 2x squared plus 3x minus 2. I think it's going to be 2x minus 1 times 1x plus 2, because then you get, oh wait, that's not going to work. Oh wait, yeah, it is. 2x squared plus 4x minus x minus 2. Okay, so there we go. So 2x minus 1 x plus 2. Great. Since the denominator has 3 distinct linear factors, the partial fraction decomposition of the integrand has the form. Okay, so there we go. So now the partial fraction, we get a over x plus b over 2x minus 1 plus c over x plus 2. To determine the values of a, b, and c, we multiply both sides of this equation by the product of the denominators. Okay. So is equal to 2x cubed plus 3x squared minus 2x. So then we multiply this. Now multiply. But this is since we have distinct linear factors. We mult by prod of denoms. So then we're gonna get a times 2x minus 1 times x plus 2 plus b times x plus 2 plus c times x times 2x minus 1 and how does that? Oh, and we say that equals the numerator? Oh, yeah, because it's the whole thing. Right. Okay, that actually makes sense. Okay, now what do you do? Oh, okay, so we expand the right side. All right, so we get a times 2x squared plus 3x minus 2 plus b times x squared plus 2x plus c times 2x squared minus x. Okay, then we expand even more. We get 2a plus b plus 2c times x squared That's actually really clever, yeah, because if you can get it in the denominator in a bunch of separate linear things, then it's just going to be a bunch of ln's, right? Yeah, it's just going to be a bunch of ln's. All right, so I think I get the idea. So, but you actually have to solve a system of linear equations. That's pretty sick. Okay, that's cool. That was fun. If they're repeated, I wonder what you do if they're repeated. This is just masochism. Why? Oh, why, Sauce? Why? That's funny. Bro, partial fractions. All right, but anyways, yeah. So okay, wait. Let's just go over this case where you have repeats. Suppose the first linear factor is repeated r times. That is, a1x plus b1 to the r occurs in the factorization. We would use. Oh wow. Okay, really? Yeah. That's brutal, man. All right, so then we get a multiplicity of 2. So then you, okay, so in the case we have repeat factors, i.e., like 1 over x plus 1 squared, our partial fractions would be like a over x plus 1 plus b over x plus 1 squared. Okay. So you need all of the things. All right, that's fine. And then you just solve. Contains an irreducible quadratic. Bro, if he gives me one of those, I'm gonna friggin' sue. I'll sue his ass. Okay, I'll write that down, but I don't expect to remember that. In the case the denom has quadratic factors. So, but then what does it end up being? You have to solve. Holy crap, dude. All right, let me just, so we have like x over x minus 2, x squared plus 1, x squared plus 4. The composition looks like a over x minus 2 plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 4. Wow. Why does that make sense? I don't know why that makes sense. Repeated? Oh my god. Give me a break, dude. Yeah, so wait. So we have a repeated quadratic. Yeah, you just do the same thing. Okay. That's crazy. If someone gives you that in a test, you're just like, dude, fuck you. Spend all my time grinding symbols. Okay, we could do these. I don't know. Right at the partial fraction decomposition of the function. I mean, this is already in, but then this one you have to factor in x squared out of it. So it's going to be x squared times 5 minus 2x. This one, oh, and it's going to be, wait, but if you have an x squared, okay, yeah, maybe we'll do this. We'll double check these answers. All right, let's switch over to here. We're going to just do a couple of partial fraction decomposition examples. If I don't do any examples, I'll forget it. All right, so do partial, whatever. So so for a, okay, so for 1b, we have 10 over 5x squared minus 2x cubed. So this is going to be equal to, so p over q. So we're going to have x squared 5 minus 2x, right? So in this case, I think you're going to have like a over x plus b over x squared plus c over 5 minus 2x. Hello. Oh, well, that's nice. Thank you for saying that. Yeah, that's very, very nice of you to say. So, but the thing that I'm trying to remember is if you have a quadratic, it's only if you have an irreducible quadratic, but if you have a linear factor of multiplicity more than one, then I think because you have repeat factors, then you just have to do this. But in the case that you have, yeah, quadratic factors, and then in the event that you have like x squared plus 1 squared in the denominator, x over this. In the event that you have this, then I think you have to do like ax plus b over x squared plus 1 plus cx plus d over x squared plus 1 squared. I think that that's what you're supposed to do. So let me just double check that that is actually the case. Okay, case 4. Repeated irreducible quadratics. Okay, so in that case, yeah. Okay, cool. So you need to do that, but only if it's a quadratic factor. But since x itself is just a linear factor, then we don't actually need to do anything. Okay, so all right, so let's okay, so this one was right. Okay, cool. All right, this is going to be problem 2A. Problem 2A. Let's see, maybe we could jump to some of the hard ones. So we're going to have x over x squared plus x. And you're not, they in this book, they say don't actually solve them, just give the decomposition. So we're going to have, q is equal to x plus 2 x minus 1. So then it's just going to be a over x plus 2 plus b over x minus 1. Okay, b, x squared over x squared plus x plus 2. This is going to be equal to, I think this is irreducible. So I think it's going to be like ax plus b over x squared plus x plus 2. Oh, wait. If they're equal, if they're equal degree, then you have to do a long division. I'll be right back. All right. All right. So what are we doing here? We're doing this one, and the reason why. So okay. So I think what you have to do is you have to do x squared plus x plus 2. So then you're gonna get a 1 here, right? So then you get a minus x squared plus x plus 2. So then these cancel, but then you get a minus x minus 2. So you're going to get a 1 you're going to go 1 plus minus x minus 2 over x squared plus x plus 2, right? So then this becomes 1 plus ax plus b over... Wait, I don't understand. Yeah, I guess that's right. All right, let's continue on. These are pretty fast, so we can just like hammer them a little bit. Okay, 3a. We have x to the 4th plus 1 over x to the 5th plus 4x to the 3rd. So this is going to be x to the 3rd times x squared plus 4. So this is an irreducible quadratic, right? So that means that this is going to have a bunch of factors, isn't it? It's going to be like a over x plus b over x squared plus c over x cubed plus dx plus e over x squared plus 4. Yep. Okay, that's fine. That one's pretty easy. All right, I don't know how many more of these I'm gonna do. Just do maybe. Let me just do the last one because it might be the hardest. 6b. All right, so this is gonna be x to the 5th plus 1 divided by x squared minus x times x to the 4th plus 2x squared plus 1. Okay, so I think that first off you have x times x minus 1 times, and I think that this might be x squared plus 1 squared, right? Let me just double check that, because it's going to be x to the 4th plus 2x squared plus 1. Okay, so this is true. So let me have over x to the 5th. And the degree is greater, so we can just move on. So then this is going to be equal to a over x plus b over x minus 1 plus, and this is going to be cx plus d over x squared plus 1 plus ex plus f over x squared plus 1 squared. And just double check that one. But I'm pretty sure, I mean, these are pretty easy. All right, and then we'll do one of the hard ones on the integral. So we'll do some nasty integral. Okay, yeah, that was easy. All right, so now we're going to do some integral. And evaluating the integral requires actually solving the linear system. So let's pick like, all right, well, we'll do a few of these. I kind of like these. These are kind of fun. Oh man, it keeps slipping. I need to go find my. Okay, my electrical tape. All right, 7. The integral of x to the 4th over x minus 1. I mean, I think that the only way to do this is first x to the 4th, x minus 1, x to the third. This is going to be minus x to the 4th minus x to the third. So these cancel, and then you get minus x to the third. So then you want minus x squared. So you're going to get minus x cubed plus x squared. So then these cancel. This becomes a minus. So then you get minus x squared. So then you do plus x. So then you're going to get minus x squared plus minus 1. Or no, plus x. So then these cancel, and then you just get x, right? And is it plus or minus? It's going to be plus. So then you want a minus 1. So then this is going to be a minus x plus 1. These cancel, then you get a minus 1. So then it's minus 1 over x minus 1. I'm just going to quickly double check that because I don't know if that's right. All right. So wait, so does this, okay, hold on. Let me just try this. So if we have x to the 4th divided by x minus 1, that's definitely the simplest, but let's just see if we can do expand. Polynomial quotient. X to the 4th, x minus 1. X. No, wait, but I want... Wait, why is it all pluses? All right, I'm just gonna ask ChatGPT. Help me do polylong div on x to the 4th divided by x minus 1. Yeah, okay, so for some reason I kept flipping the signs, which was... Oh, because this is a plus. This turns into a plus. Yeah, so this needs to be like this and like that. So you get x to the fourth, so you get, yeah, so then you get minus, so you get this, so then you get x squared, then you get this, then you get 1. Okay, and the remainder is... Oh, but this is supposed to be a -1, so this is a +1. Okay, alright, that was good. So this is the final thing. So now we're going to get the integral of x cubed plus x squared plus x plus 1 plus 1 over x minus 1 dx. So this is going to be x to the fourth over 4 plus x to the 3 over 3 plus x to the 2 over 2 plus x, and then the integral of 1 over x minus 1 dx is equal to the integral of 1 over u du, which is equal to ln of u, which is equal to ln of x minus 1. So this is just going to be plus ln x minus 1 plus c. All right, so let me just ask. All right, let's do a few more. All right, so number 8 is the integral of 3t minus 2 over t plus 1 dt. All right, so since the degree is the same, we need to do a long division. 3t minus 2t plus 1. So if we do 3t divided by t, we get 3. So we're going to have a 3 here. So it's going to be minus, so it's going to be 3t plus 3. So this becomes a minus 5. So then all we're going to get is 3 over t plus 1 minus, wait. No, we're going to get 3 minus 5 over t plus 1. So that's, okay, so then we just have to take the integral of 3 minus 5 over t plus 1 dt. So this is 3t, and this is going to be minus 5 ln t plus 1 plus c. I think that might be right, but I'm going to double check. Okay, so the first one we got right. The second one, 3t minus 5 ln t. Okay, that one's correct. All right, so now we can move on to number 9. Number 9 will be fun. It's going to be the integral of 5x plus 1 over 2x plus 1 x minus 1 dx. So since the degree on the denominator... Okay, so this is the first one where you actually have to do the... okay, so this is going to be a over 2x plus 1 plus b over x minus 1 is equal to 5x minus plus 1 over dot dot dot, which is this stuff. So, but since we're going to multiply both sides by 2x plus 1, x minus 1, what we're going to get is we're going to get a times x minus 1 plus b times 2x plus 1, because this thing is going to cancel on here, and this one's going to cancel on there. And this is just going to be equal to 5x plus 1. So then a plus 2b times x plus b minus a is equal to 5x plus 1. So our linear system is going to be a plus 2b is equal to 5. And b minus a is equal to 1. So let's just say b is equal to 1 plus a. So then we're going to get a plus 2 plus 2a is equal to 5. So then 3a plus 2 equals 5. A is equal to 1. So then b is equal to 2. So now we can finally rewrite our integral. So we're going to rewrite our integral as the integral of 1 over 2x plus 1 plus 2 over x minus 1 dx. So this is going to be, I think this is going to be, so if u equals 2x plus 1, then du is equal to 2 dx. Which I think means, so we're actually going to have ln of 2x plus 1 over 2 plus, and this is going to be 2 ln x minus 1 plus c. Let's double check. Okay, so we got a and b right. And we got the integral right. All right, that was fun. That was good. I'm feeling so much more comfortable with doing integrals now. I mean, it really just took like 3 days of review, and now my derivatives are stronger again, and my my integrals are pretty strong. The only thing that I think let me think about it. I definitely don't know those trig integrals. Those ones are really weird. I'm never going to memorize that, though. That's just like... Okay, so what are we doing now? We're doing number 10. So this is y over y plus 4, 2y minus 1 dy. All right, so to take this integral, we're going to get the partial fraction decomposition as a over y plus 4 plus b over 2y minus 1 is equal to y over the thing. So then we're going to get a times 2y minus 1 plus b times y plus 4 is equal to y. So 2a plus b times y plus 4b, or let's just do minus a plus 4b is equal to y. So then we know that 2a plus b equals 1, and we know that that minus a plus 4b is equal to 0. So if we just say 4b equals a, then we're going to get we're going to get 8b, we're going to get 9b equals 1. So b is equal to 1 over 9, then that seems wrong. I don't know why that seems wrong, but so now we get 2a is equal to minus 1/9. Oh, wait, no. 1 minus 8/9. So this is equal to what? 16/18, which is so 8 over, wait. It's just going to be 4 over 9. Yeah, what am I? That was silly. Okay, yeah, so a is equal to 4/9. So then we're going to get 4 over 9 y plus 4 plus 1 over 9 2y minus 1. We need to do this integral. Isn't it just going to be 4/9 ln y plus 4 plus 1/9 ln? Oh wait, this is going to be 1 over 18 because you have to divide by 2 for this factor. So then we get ln 2y minus 1 plus c. Double check. All right, so we got A and B correct. So we get 4/9 ln y plus 4 plus 1 over 18 ln y 2y minus 1. All right, cool. So we did it. We did do it right. All right. Problem 11. Let's skip the, I don't care about the definite integrals. Let's go to 13. All right, we have the, oh wow, okay, this one's fun. Integral of ax over x squared minus bx dx. Let me just make sure I'm in the shot. All right. So this is going to be equal to, wait, but this one's easy, right? Because then you get a over x minus b. And that partial fraction is just going to be a over x minus b is equal to a over x minus b. Then you're going to get a is equal to a. So wait, can't you just, so I think that this integral is just becomes ln a ln x minus b plus c. I think that that's the whole thing. I don't think there's anything else there. All right. The next one I want to do a hard one. Okay, 18 looks pretty hard. Okay, so 18 is the integral of x squared plus 2x minus 1 over x cubed minus x. All right, so we don't have to do any long division, but what we do have to do is x times x squared minus 1 becomes x times x plus 1 x minus 1. So then we're going to get a over x plus b over x plus 1 plus c over x minus 1 is equal to x squared plus 2x minus 1 over da da da. So then we're going to get a times x plus 1, or we'll do the expansion immediately. So we're going to get x squared minus 1 plus b times x squared minus 1. Oh, interesting. Plus, wait, that's not minus x. Yeah, I was like, what? How is that possible? Plus c times x squared plus x. And that's equal to x squared plus 2x minus 1. All right, from here, though, we're going to get a plus b plus c is equal to 1, right? Because, and then we're going to get minus b plus c is equal to 2. And then finally, minus a equals minus 1. So, okay, so a equals 1. So then we have b plus c equals 0 and minus b plus c equals 2. So 2 minus b, so b plus 2, wait, what? Wait, I didn't do this right. Wait, b is equal to minus c. So minus c is, so 2c is equal to 2, so c equals 1. B equals minus 1. Okay, that was kind of cringe, not going to lie. So then we're going to get the integral of 1 over x dx plus the integral of, or I guess minus the integral of 1 over x plus 1 plus the integral to dx plus the integral of 1 over x minus 1 dx. So this is just going to be ln x minus ln x plus 1 plus ln x minus 1 plus c. Pretty sure that's the right answer. What problem was that? That was 18. 18. ln x plus ln x minus 1 plus minus ln. Okay, yep. Did it right. All right, do we have any? All right, I feel like we could probably move on, right? How many more of these do I need to do? Let's try to go to the last problem. Let's do the hardest one. All right, so the last problem of this whole partial fractions stuff is, all right, it's going to take me a second to write out even. All right, this is problem 38, section 7.4, 7th edition of Stewart's early Transcendentals. Let's fucking go. X cubed plus 2x squared plus 3x minus 2 over x squared plus 2x plus 2 squared. Oh, geez. Okay, yeah, so this is an irreducible quadratic with multiplicity. So what we're going to have, so the maximum degree here is greater than the top. So deg q greater than deg p, where this is p and this is q. It's a standard notation. So then what we can do is we're going to say ax plus b over x squared plus 2x plus 2 plus cx plus d over x squared plus 2x plus 2 squared is equal to this whole thing. So then what we're going to get is we're going to get ax plus b times x squared plus 2x, because we can't factor this anymore, which is unfortunate, right? Wait, can we? Wait, x plus 2, x plus 1. Oh, shit. X squared plus 2x. No. See, that doesn't work. So you can't factor this. So then this is correct. So then we're going to get plus 2x plus 2 squared. So we should probably expand this. Okay, so let's just do that. X squared plus 2x plus 2. X squared plus 2x plus 2. I can't FOIL in my head. X4 plus, we're going to get 2x cubed plus 2x squared. Okay, then plus, so we did this one, and this one. So now we need plus 4, and then I think that we just double these. These become 4, and this becomes 4. So we're going to get x to the 4th plus 4x cubed plus 4x squared plus 4. Okay, so that's in front of this. So we're going to get ax plus b times x to the 4th plus 4x cubed plus 4x squared plus 4 plus cx plus d time, and this has to be in parentheses, and this has to be in parentheses, times x squared plus 2x plus 2 is equal to p. Okay, so to do this, we, oh shit, is this really how you have to do this thing? This is psychotic. All right, so ax to the 5th plus ax to the 4th. Oh wait, 4ax to the 4th plus 4ax to the 3rd plus 4ax plus b, let's do this, bx to the 4 plus 4bx third plus, wait, this should probably be a, wait, I think I missed some stuff here. I totally missed some stuff. All right, this is making me realize this problem is like so much symbolic manipulation. Because I missed the degree 1 terms. Because this needs to be, I think this needs to be 8x. No, wait. I think this needs to be 4x. And this becomes 8x and then plus 4. So we needed an 8ax plus 4, right? But this is going to be 4ax. Wait. No, this is squared. This is this. Okay, there. That's what it's at. So now this is going to be 4bx squared plus 4b. Wait. Oh, because we forgot. Yeah, because I'm going off of this, and this needs to be plus 8x. So this is going to be 8b plus 4x plus 4b. Plus, so now we need to do the c expansion. So this is going to be cx cubed plus 2cx squared plus 2cx plus dx squared plus 2dx plus 2d. Guys, hold on. It's always worth taking a little break. New math book, baby. I realized I didn't have any linear algebra books. I want to work through this in lean. I really want to do this last night, and I saw Terrence Tao just blowing through lean, dude. I want to do more lean. Okay, let's hop back into the problem though, because the problem is okay. So now we need to devise our system of equations. So I think A needs to equal 0, right? I think B also needs to equal 0, right? Because how could this be if there's no, so then, okay, but here, so then C must be equal to 1. So then here we have, this is our second degree, so then we're going to have 2C plus D is equal to 2. So D is equal to 0? Is that for real, dude? I think I did something wrong. Yeah, there's something wrong in here because we need, yeah, because D can't be 0. Because we need 2C plus 2D equal to 3. And then similarly, 4B plus 2D is equal to minus 2. All right, maybe I'm going to bail on this problem. Let's just see how close we got. Oh. How did it solve for A and how did it solve for all that? Oh my god, dude, really? I don't think this thing is right. Is that for real, dude? Okay, yeah, so maybe maybe I shouldn't have picked the hardest one. All right. So that was fun. Oh, this section is going to be legendary, dude. See, it's already 11:40. How long we been going on this one? 2:30. All right, let's just jump to the problem. Oh yeah, this is bro. This is where you're just like, um, yeah, just a page just full of integrals to take. All right, man. Okay, so let's just hop in, right? Should we just freaking do it? All right, so 38 was too hard. I don't know how I did that wrong. But if I get anything like that on a test, bro, I'm suing his ass. I'll sue your ass. Where is this from though? Okay, I'll show you. Okay, so this is from James Stewart, Early Calculus, Early Transcendentals, 7th edition, section 7.5. This is where all these integrals are coming from. Thanks for the question. All right, let's do number 1. It keeps zooming in too much. I need to go find my electrical tape. I don't know where I put it. I had it yesterday. Okay. Integral cos x times 1 plus sine squared x dx. All right. So for this one, I'm thinking that we can turn, because sine squared x is equal to 1 minus cos squared x, maybe we like turn this into like 2 minus cos squared x. Oh wow, man. When you don't know which rule to use, these become a lot harder. Uh, if you did a u sub, it's because I doubt the first one would be. If you do a u sub and we say u is equal to sine x, then du is equal to cos dx. So then du over cos x equals dx. So when we substitute this in, these cancel, and then we get just the integral of 1 plus u squared du. This is going to be equal to u plus u cubed over 3. So this is going to be equal to sine of x plus 1/3 sine cubed of x plus c. All right, hold on. I'm just going to get my double checked answers all set up. But I'm pretty sure that one's right. All right, let me look at which one we want to do next. Oh wow. Problem 2 is I think, can't you do like a trick where you get rid of this, but you change the bounds of integration? We'll need to look at that because I don't remember how to do that. I gotta get some water. Okay. Yep. So we got the first one right. Okay. Wait, hold on. So what ChatGPT said was you let t equal 3x plus 1. But okay, so if we do 1/3 integral t to the square root of 2 dt, does that become... So first off, yeah, I guess this is good practice on figuring out what the rule is when you change the bounds of integration. All right, if we just leave it at 0, 1. So I think what you have to do is 3 times 0 plus 1 is equal to the lower bound, because 0, plug in for the substitution, so this becomes 1. And then 3 times 1 plus 1 is equal to 4. So I think that this does need to be 1, and this needs to be 4. So then this is going to be 1 over 1 plus root 2 times t to the t squared plus 1, root 2 plus 1. And this is going to be over 3. So we need to evaluate this at 4. So we're going to get 1 over 3 times 1 plus root 2 times 4 to the square root of 2 plus 1. Dude, I don't even know how to evaluate this. I think you just leave it like that. You know, minus the 1 times square root 2 over 1, etc. Okay, so that's that one. We're not gonna compute all of that. It's more about doing the symbolic integration than it is anything else. Oh God. Okay. Sine cubed x over cos x dx. So sine cubed, I'm pretty sure what we could do is we can take, so one way to look at it is it's sine squared tan. Another way to look at it is you could do sine 1 minus cos squared over cos, but I don't really feel like that helps you at all. This is that thing from trig integrals. What is the trick that you're supposed to do? Then you do a u sub. So if you do this and then you u sub, then you get du is equal to minus sine dx. Then you can cancel this, and then you end up with 1 minus u squared over u. That's not that easy. Okay, so what ChatGPT did was it turned okay, so it took wait, what? I think it just didn't even do the right problem. Wow, this section really is just, here's the 82 integrals to solve. That's crazy, man. All right, so let me think. Oh, wait. Oh, I'm doing number 4. This is number 4. But if you do this, you get sine minus sine cos, and this is going to be over cos. But then you can cancel one of these, and this just becomes tan minus sine. So then you get sec squared minus plus cos plus c. I think that this is all you have to do. All right, so that one was actually really easy. Wait, I did it wrong. Oh, because this isn't sine, this is sine cos. Oh, you definitely get this. Wait. Oh, wait, no, this is the derivative. The inner. Oh, yeah, yeah, yeah. Okay, wait. Let's do this for real instead of cheating on the answers. Okay, screw this. We're gonna start with number 3, like I was supposed to. All right, we're gonna come back to that one. Okay, so we have integral of sine x plus sec x over tan. So if we look at this, we get sine over tan, which is equal to sine times cos over sine, plus, and this is going to be cos over sine times 1 over cos. Okay, so we're going to get the integral of cos dx plus integral of cosecant x dx. So this is just going to be sine x plus, and then, so the integral of cosecant, how do you do that without memorizing it? That is the trick there. Figuring out the integral of cosecant. How do you remember that? All right, well, let's just look at the derivative of cosecant x is equal to the quotient rule of 1 over sine. So then we're going to get f and this goes to that, and then f is equal to 1, so then you're just going to get minus cos over sine squared, which is equal to cot cosecant minus cos cosecant. So that's not that illustrative, honestly. I don't know how do we take the integral of cosecant? Oh shit, it's actually like, yeah, okay. The integral of cosecant. Okay, wait. In the book, they give you a big table though. The integral of cosecant. Okay, this integral becomes ln cosecant x minus cotangent x. That's crazy. I'm never gonna. What? Okay, but if that's the case, then the answer is sine plus this plus c. Okay. Wow, these are hard, dude. I was not expecting them to be this difficult right off the bat. Okay. Let's see if there's any. All right, so we're going to go back to number 4, which was this crazy trig one. Sine cubed, the integral of sine cubed over cos. So then we get integral of tan minus. Okay, okay, so wait. The integral, how do we integrate sine cos? That's actually, you know what I want to know though? This thing is so freaking annoying. Huh. Okay, all right. Let me think about how you take this one. This one is obviously. Wait, I think the integral of tan is actually hard too. Dude, integrals are so much harder than derivatives. Kind of nuts. The integral of tan is the natural log of secant. Okay, you do a u sub on the replacement. Okay, that looks like it's going to work. Okay, I don't think we've done this one. So the integral of tan x dx is equal to the integral of sine x over cos x dx. If we let u equal cos x, and then du is going to be equal to minus sine dx, right? So to each their own. I mean, at some point it's gonna click, right? Anyways, plus reading books is better than watching videos. All right, so we can just replace du over sine is equal to dx. So we're gonna get the integral of sine x over u times du over sine. These cancel, so then you're just gonna get minus ln of but this is cos. Yeah, it's cos. Okay, so this is the integral of tan. Now we just need to take the integral of sine x cos x dx. I think you can do the exact same thing. You let u equal cos, then du over minus u is equal to dx. So then you get the integral of sine times minus times u times du over, this is a minus out here, over sine. These cancel, and then you just get minus, well, yeah, we can just do this. You get minus u squared over 2, which is equal to minus cos squared x over 2. So to put it all together, the final result is going to be minus ln, and there's a minus here, and a minus here, so it's going to be a plus. So these two minuses cancel. So we get minus ln cos x plus cos squared x over 2 plus c. All right, let me double check. This was number 4. Minus ln cos x. They got a minus sine squared over 2. Let me see. Okay, I just want to do this really quickly again. If you let u equals sine, then you get du over cos equals dx. So then you get the integral of u cos du over cos. This cancels, then you get, minus sine squared over 2. So I think that this is actually equivalent to minus sine squared. Because if we replace cos squared with plus 1 minus sine squared, I'm pretty sure that is equivalent. I'm almost positive that it's equivalent. Oh yeah. All right. It's the same up to the constant on C. Right. So it's the same family. All right. Number 5. Let's get it. I mean, practice is just the only way, man. It's going to just take a while. Okay, all right. So there's 2 ways to do this, I think. We could do some long partial fraction thing. We get... No, you can't even do partial fractions here because we don't know. I mean, the book doesn't even explain how you could do partial fractions where your irreducible form is of degree higher than 2. So what you have to do is you have to let u equal t squared. So then du is equal to 2t dt. So then what you're going to get is the integral of t over u squared plus 2 times du over 2t. This cancels and you get a 1/2 here. I think that this gives you like an inverse tangent or something weird. But I think it's one of those ones you kind of have to memorize. Let me look at the table. Yeah, it's I knew it. It's an arctan. But like that one, I wanna get a derivation of it. Let's see. Derive integral of what is it? It's going to be 1 over x squared plus, let's just do 4. Doesn't really matter. But I don't just want the answer. I want to know how they got to it. Like, what are you supposed? Because I guess you just do a second. No, see, that's what I'm. Wait. Mm-hmm. Okay, yeah, this is what I was imagining. Okay. Oh. So you get yeah, you like u equal 10. This is smart. Yeah, okay. That's very interesting. So then you substitute with secant and then you get, but then it cancels and you just get theta plus c. Since theta is equal to arctan u, wow. Okay, we're gonna work that one out on paper. Okay, so here's what we do. We want this integral. We're gonna say u is equal to tan. Oh wait. Yeah, there. Let's call it tan. Fine, we'll keep the theta. Then du is equal to sec squared theta d theta. So if you do the u sub, we're gonna get rid of this 1/2 just for fun. So we're gonna get 1 over tan squared plus 2. That does complicate it a little bit. Let's just do it 1. Or no, yeah. What about if it's u2 plus 2 in the denom? Do trig sub. So if this is a 2, because then you can't just replace this with secant squared. This is all right. All right, hold on. We're going to do it like this. So the integral of 1 over u squared plus 2 du. Is it in frame? All right, we're going to let u equal root 2 tan theta, where du is going to be equal to root 2 secant squared theta d theta. Then we do the u sub. So first off, u squared plus 2 is going to be equal to 2 tan squared theta plus 2. Okay, okay. And because you can do this, this is equal to 2 times 1 plus tan squared, which is equal to 2 sec squared. Okay. So that's how, so you just need to remember that you have to add a square root factor for whatever this is. Okay, now the next step is to rewrite the integral 1 over 2 sec squared theta times, and this is going to be, so we have du here, so this becomes times root 2 sec squared theta d theta. This cancels, so then we just get root 2 over 2 integral of d theta is equal to root 2 theta over 2 is equal to root 2 oh yeah, and so this is, wait, this is going to be theta is equal to u over root 2, so it's going to be a tan u over root 2. Right, and you can't delete that. Okay, so there's that. So now that we have this, all right, I'm going to start it over now that I'm just going to remember that we get what is it? So if you have, it becomes 1 over, so if we have the integral of 1 over x squared plus a, then this becomes 1 over root a tan x over root a. Okay, all right, so that's the rule. And that's the rule that's in the little table. Oh, wait. Yeah. Yep, that's correct. Okay, we are almost done with number 5. So t over t to the 4th plus 2. So we let u equal t squared, du equal to 2t dt. So then we get 1/2 the integral of 1 over u squared plus 2 du. This becomes 1/2 times 1 over root 2 a tan u over root 2. But then to rewrite this as t, this becomes we just change this to a t squared. So I'm pretty sure that is our answer. Yep. All right. Oh yeah, plus c. All right, number 6. Let me see if number 6 looks good. Okay, well, I'll do number 6. We'll see. So this is the integral from 0 to 1 of x over 2x plus 1 cubed dx. All right, so I'm going to let u equal 2x plus 1. du is going to be equal to 2 dx. So then we're going to get 1 and 3 up there. But this actually is not a very good idea because the other way of doing it is we could do a over 2x plus 1 plus b over 2x plus 1 squared plus c over 2x plus 1 cubed. And then this is going to be equal to x over 2x plus 1 cubed. But that seems really like not the right way. But we need to get rid of this x in the top. Oh, wait. All right, I don't want to freaking cheat. Let's just see if this will work. But this is going to be brutal because to evaluate this is going to be so many terms. Okay, so it's going to be 4x squared plus 4x plus 1 is, let's call this is q squared or something. That's not really whatever, but then this times q3 is going to be equal to, I have 6 terms, so this is going to be 8x cubed plus 8x squared plus 2x plus 4x squared plus 4x plus 1. Then we combine like, it's going to be 8x cubed plus 12x squared plus 6x plus 1. So this is C. This is what's under C. So now we multiply both sides by x plus 1 cubed. Then we're going to get a times 4 squared plus 4x plus 1 plus b times, and we're only going to get 1, right? This is going to be 2x plus 1 plus c is equal to x. So now we really only have to figure out, so a must be 0, right? Oh, I hope I don't make this mistake again. If a is 0, then 2b is equal to 1. So then b equals 1/2. But so then doesn't that make the integral 1/2 1 over 2x plus 1 squared? If I got that right, I'm going to be ecstatic. Because just one u sub doesn't do it, right? Because you end up with 1/2 the integral of x over u cubed du. Oh, but maybe you can... Can you do like a type of thing? Oh, wow. That's a really tricky integral. Yeah, okay, so what they did is they did change the numerator. Okay, so let's scratch this. But I don't know why my partial fractions keep failing. Okay, so the integral... All right, so the trick here is that you turn this into u minus 1/2 times u minus 1 over u cubed du. And now... Oh, you just turn this into 1 over u squared plus minus 1 over u cubed. All right, but I actually want to try this. If we have a over u cubed, or over u, plus b over u squared plus c over u cubed is equal to u minus 1 over u cubed, and then you do this thing, u cubed, then you get a u squared plus b u plus c is equal to u minus 1. So then b is equal to 1 and c is equal to minus 1. So then you get 1 over u squared plus, okay, or minus c 1 over u cubed. Okay, so at least the partial fractions is, I'm not like completely botching it. But so then you get this and then this, and you get minus 1 over u, and then this is going to be minus 3. This is going to be u to the minus 3 becomes u to the minus 2 divided by, so this is going to be plus 1 over 2u2. So I think that this... Yeah, minus plus 1 over 2 Okay, so this is correct. So then you just substitute it back in. Very nice. Ooh, this one's cool. This one's cool. I think I'm about to make us some lunch, but we're going to keep doing these. Okay, so let me just introduce the problem. So 7 is the integral of e to a tan y over y plus 1 plus y squared. Okay, so the reason why this is cool is I think if we take u equal to a tan, then du is equal to, isn't it 1 over 1 plus u, or y, 1 y dy. So then 1 plus y squared du is equal to dy. So then we're going to get the integral of e to the u over 1 plus y squared times 1 plus y squared du. These cancel, and then you just get is equal to e to the a tan y plus c. So that one's really fast. I can't imagine I got that one wrong. That one's really easy. Okay, yeah, I got it right. Okay, good. Mathematica gave me something really weird, but we got that one right. That one was easy. T times sine t times cos t dt. It seems like an integration by parts. All right, let's just guess that u is equal to t sine t du is equal to, this is going to be sine t plus t cos t dt. Now dv is equal to cos t dt. V is equal to sine t. Okay, so we're going to get t sine t sine squared t minus the integral of sine t times du, which is sine t plus t cos t dt. This is going to be equal to sine squared t plus t sine t cos t. Do we think it works out? Oh, you know what? Though I think I see. I mean, we could also do this sine plus t cos t, but that doesn't look very promising. But maybe like a 1 minus cos squared t plus t sine cos. Yeah, it doesn't look very... Wait, actually? We can do this one, we can do this one. Then it's just a matter of doing this one. But this is really hard. I don't know how to do that. Oh, wait, actually... Wait, what if we u sub... What if we just let u equal t sine t? Du is equal to sine t plus t cos t. That's what you need to do. That's easy, man. Right? Because... Hold on. No, because you can't cancel the... What does this function even look like? I want to get a look at it. X sine x times cos x. For some reason, this thing always fucking breaks. That's an interesting function. If you let u equal cos, or what about just sine? Then you have du is equal to cos. But then you still end up with like tu, and I don't know how you integrate with tu. I think that there's an identity here. I think that they want you to just memorize that there's an identity there. Because in the section on trig substitution, not trig substitution, and trig integrals. Right, okay, because there's an identity that sine t cos t is equal to 1/2 sine 2x, or 2t. So then if you have integral of t sine 1/2 t sine 2t, can you not just then do integration by parts on this? Let's try that. That seems like a good strategy. This is going to be plus 1/2 cos 2t dt. It's going to be equal to 1/4 cos 1/4 sine 2t. Okay, so then the whole answer is going to be minus 1. This is going to be 1/2 minus t cos 2t plus 1/2 sine 2t plus c. I feel pretty good about that. That's number 8. Oh, I missed this 1/2. This is a 1/4. Nice, we got it. All right, I just missed this, but almost right. All right, I'm gonna make some food. Maybe I'll start this back up in a bit. How many? We did 3.5 hours of integrals. I feel a little more confident, but actually this section. So I was feeling confident, and then I started this section, and now I'm feeling less confident because recognizing the strategy is definitely tricky. All right, let's just scan some of these ones. X minus 4x, x minus 5, x plus 1, x minus 5, x plus 1. I think that this one's a partial fraction. This one looks like a integration by parts. Oh wait, you can't see anything. Hold on. Let's just go through these. So this one looks like an integration by parts because you're gonna get, if you let u equal this, and you let no. I think you want to let u equal ln. Yeah, if you let u equal ln, then it yeah. Okay, that's how you do that one, I think. Now this one. Oh, see how this? Okay, so this one's harder because I'm almost positive the way that you do this one is you do a partial fraction, but you have to do a irreducible quadratic in the denominator partial fraction. So you have like an ax plus b over the thing, and then you have to like. So maybe 11 would be good because I didn't really do that many examples of that. This one, I don't think you can reduce that at all. Maybe you do like a weird complete the square thing. I don't know. Oh, you know what you mean? If you let u equal x squared, then you get u squared plus u plus 1. And it cancels the top. But 1 over u squared plus u plus 1. I still don't really know how to do that. Okay, this is that trig sub. We'll definitely do this. Let me just write down these. So I do want to do 9. I want to do 10 because I think I know how to do it. I want to do 11. I want to do 12 and 13. This one maybe is an interesting one. All right, so we're just going to keep doing all of them, I think. That's sort of the plan. All right, peace out.